Hey, video problem 58 topic, the combined gas law. So I don't really do the gas laws by themselves. I just typically do the combined gas law, which is P1 V1 over T1 is equal to P2 V2 over T2, because this has all the gas laws, hence the term combined gas law. So it just makes it easier to only use this one problem. So the only thing you have to really know is temperature has to be in Kelvin. Everything else can be in whatever unit it is, so long as it's the same unit on both sides, and you'll see that in this first problem here. Right? So a 1.2 cubic foot sample of gas. So what is that? That is actually a volume. Right? So volume is equal to 1.2 cubic foot. So do it like that. Of a gas is at a pressure of 0.8 atmospheres. So check it out. This volume and this pressure occur at the same time, right? 1.2 cubic foot of gas at a pressure of 0.8 atmospheres. So I'm going to call them both 1. I could call them anything. I could call them A, I could call them elephant, I could call them anything, but I'm going to give it the symbol of 1 to show that they occur at the same time. The gas is then placed into a 0.95 cubic foot container. So the new volume is 0.95 cubic foot. So we're changing something about this gas. We want to know the new pressure. So let's see, we got P1 V1 over T1. Let's use our combined gas law here. Notice they didn't say anything about temperature, so I cross it out. Right? I'm looking for P2, so I'm going to divide both sides by V2. Right? Multiply by 1 over V2 is basically all I'm doing here. Right? So I end up with this equation, P1 V1 over V2 is equal to P2. And then I can just plug and chug. So it's 0.8 atmospheres. Let's see, what's V1? 1.2 cubic foot. Not a unit I'm used to. V2 is 0.95 cubic foot, but take a look, the unit cancels out, so it doesn't matter that I'm not used to it. So I got this new pressure. So let's see what we get. We get 0.8 times 1.2 divided by 0.95. So you get a value of 1.01. How many sig figs? Looks like I should only have one sig fig, so I'm going to call that 1. Okay, so there's our new pressure. Look at this one. A gas occupies 0.85 liters, so that's a typical volume, 0.85 liters, of space at a temperature. So here's a temperature of 25 degrees Celsius. Determine the new temperature. So these are V1 and T1. This is T2. That's what I'm looking for. If the gas is placed into a 1.5 liter container, so the new volume, 1.5 liters. Now temperature, you can't use Kelvin, so we have to add 273 to that. So that's 298 Kelvin. Let me just show you that up here. So the T1 is equal to 25 degrees Celsius. To turn it into Kelvin, temperature Kelvin is equal to temperature Celsius plus 273. Okay, so I just add 273 to that Celsius temperature. I get 298. So we're using P1 V1 over T1. We are changing the gas. So since we're changing the gas, we're going to use that combined gas law. We don't say anything about pressure, so let's get rid of that. And very important here, we are solving for T2, right? So we got to get T2 out of the bottom first. You know, let me do this with numbers. All right. So we've got 0.85 liters over T1, which is 298 Kelvin, equal to V2, 1.5 liters, over T2, which is what I'm looking for. So a lot of times students will divide both sides by 1.5, and that's the wrong way to do it. Now you may be thinking, why don't I just cross multiply and divide? Fine, you can do that. But what I'm going to do here is I'm going to multiply both sides by T2. Right, so that gets T2 out of the bottom. So I end up with this T2 times 0.85 liters all over 298 Kelvin is equal to 1.5 liters, and then I'm just going to basically multiply by 298 divide by 0.85 on both sides. Right? So that's going to be 298 Kelvin on top. Then I'm multiplying by, getting rid of 0.85 liters on the bottom, so liters cancel out. So I've got 1.5 times 298 divided by 0.85. Right? So that's 526. And that's going to be Kelvin. I only want 2 sig figs, so I'm going to make it 530 Kelvin. Let's see, does that make sense? I'm taking 0.85 liters. Now it's in a 1.5 liter container. Yeah, so if the pressure remains the same, we're going to have to increase the temperature. Yeah. Okay, that makes sense. All right, number 3, a gas at STP. What's STP? The temperature is 0 degrees Celsius, which is 273 Kelvin. The pressure is 1 atmosphere. And this says that it has 7.8 liters of space. Determine the new volume, so V2 of the gas if the pressure is increased, so P2 to 3.4 atmospheres. And the temperature, we're dropping the temperature to negative 15 degrees Celsius. So what is that? That's 273 minus 15. 258. 258 Kelvin. All right. So we're got P1 V1 over T1 is equal to P2 V2 over T2. Nothing disappears. I'm solving it for V2. So let's multiply both sides by T2 over P2. So those cancel out. So I got T2 times P1 times V1 over P2 times T1, and that's all equal to V2. All right. So let's see. I got 258 Kelvin times 1 atmosphere times V1, 7.8 liters. That's all over P2, 3.4 atmospheres times T1, 273 Kelvin. So Kelvin cancels out, atmospheres. I'm left with volume. Is that what I'm looking for? That's what I'm looking for. So, yeah, plug and chug. 258 times 1 times 7.8 divided by 3.4 parentheses times 273. I get a value of 2.168. Again, I'm looking at 2 sig figs here, so 2.2 liters. There you go. Couple of combined gas law problems.